In this section, we're going to be going over compound interest. So first, just a couple of definitions. For the first one is an investment. An investment is the use of money to make more money, essentially. So it's the use of money for income or profit. And we can divide investments into two classes: fixed investments and variable investments. For a fixed investment, the amount invested as a principal is guaranteed, and the interest it is computed at a fixed rate. So two examples of this are savings accounts and CDs, or certificates of deposit. For a variable investment, the principal nor the interest is guaranteed. So examples of this are like stocks, mutual funds, and commercial bonds. So let's get into compound interest now. So we did simple interest already, and now this is going to be compound interest. Compound interest is going to be interest that is computed on the principal and any accumulated interest. So unlike simple interest, the interest is going to be computed periodically for compound interest, and that's going to mean like daily, monthly, quarterly, semi-annually. And then it adds that interest to the principal. The interest then for the next compounding period is going to be computed using this new principal, which is the original principal plus the other interest that was accumulated. So what this really is computing interest on interest. And the formula that we're going to be using for this is going to be right here. It's going to be A equals P times 1 plus R over N raised up to the NT, where A is the amount that accumulates in the account. It's essentially the total amount. P is the principal. R is the annual interest rate as a decimal. N is the number of compounding periods per year. And T is the time in years. So some certain values for N that we will be seeing are going to be daily. So if it's compounded daily, we're going to use that banker's rule that we talked about and say that N equals 360 for 360 days in the year. Once again, that was from rounding. And then we can have monthly. Monthly, that means there are 12 compounding periods, 12 months in the year. And we can have quarterly. Quarterly is 4 times per year. And we can also have semi-annually, which semi pretty much means to chop in half, so twice per year. So those are the 4 main ones that we're going to be using for our N values. So let's go ahead and see an example. Mrs. Miller works as a sales rep for Kellogg's. She recently received a $1,000 bonus for reaching her annual sales quota, and she deposits the $1,000 in a 1-year certificate of deposit, paying 2% compounded quarterly. We want to determine the amount, which is A, to which the $1,000 will grow in 1 year. And we're going to do this 2 ways. First way is going to be using the simple interest formula, and we're going to have to do that a couple times. And then the second way is going to be using the compound interest formula. So using the simple interest formula, what we're going to have to do here, since this is quarterly, we have to compute it 1 quarter at a time. So we're going to have to do the first quarter and then the second quarter using the new principal, the third quarter using the new principal, and then the final quarter using the new principal. So then we can see that we won't really be doing it this way, but we'll get the same answer. So first quarter, we need to use our simple interest formula, I equals P times R times T. And we have P is the $1,000, and R is the 2% as a decimal, that's 0.02. T is going to be, since this is quarterly, Quarterly is 1/4 of a year, so 0.25. So let's just go ahead and plug these values in. That's going to be 1,000 times 0.02 times 0.25, and just plug that all in a calculator, and we end up getting 5. So the interest is actually just $5 after the first quarter. So that means the total amount is going to be the principal. So I'll just use the variable notation. The principal plus the interest, that's going to be 1,000 plus 5. So that's going to be $105 for the first quarter. So we're going to do the same thing, except now we're going to be using 1,005 as the new principal for the second quarter. Okay, so same exact formula. We're going to have I equals PRT. The P, like we just said, is going to be this value right here. And let's go ahead and plug it in. That's going to be 1,005 times the interest rate, which is the same, 0.02, times the time. It's still quarterly, so 0.25. And we plug all of that in, and we get an interest of, I'm going to put about, because I'm rounding a little bit, about $5. I'm going to label these interest because it's money, $5.03. So you can see the interest is going to be getting a little bit more each time, and the new amount now is going to be, once again, that new p-value plus I. So that's going to be 1,005 plus $5.03. So the new principal that we're going to be using in the next one is $1,010.03. And let's go ahead and do it for the third quarter, and we'll do this one a little bit quicker. So we have our formula, and we're going to plug in our values. The new p-value we're using is the one that we just found from the second quarter. So that value for p times the same interest rate times the same time, and we plug all this in, and we get about, once again I'm rounding, we get about $5.08. So the new amount is going to be $1,010.03 plus the $5.08, and this is going to end up giving us, oh, actually that should have been $5.05. I jumped ahead to the next one. So that was $5.05, not 8 cents. And we add these up, and we get $1,020 and or $1,015.08. And just like we've been doing, this is the new P, the new principal for the last quarter. So the fourth quarter, and let's go ahead and do the same thing using that principal that we just found. And plugging in all of our values here, doing the same thing we've been doing, using the previous principal value, we end up getting an interest of $5.08, and adding that to the previous principal, we get $1,020.16. So you can see that this interest is just continuously getting larger and larger and larger. And this value right here, that 1,200 number, is the answer. So the $1,000, the original $1,000 grows to $1,020.16. Okay, so now let's do that using the formula, and we're going to be using this formula from now on. Also, it is important to note here that this number that we got, the $1,020.16, that's the compounded interest quarterly, If we just did simple interest for this whole thing, we would have actually gotten $1,020. So compounded interest ended up being 16 cents more. Okay, so let's use this formula from the previous page. Let's go ahead and write it on down. It's A equals the principal times 1 plus R over N to the N times T. And let's write down all of our givens. The principal is the $1,000. The R is 2%, which is 0.02. The N, since this is quarterly, that means 4 times per year. And then the T, this was after 1 year, so the T is 1. And let's go ahead and plug them in. So the total amount is going to be 1,000, plugging in for P, times 1 plus R over N, which is 0.02 over 4, raised up to the NT, which is 4 times 1, which is obviously 4. So when you plug this in the calculator, I recommend plugging in this first, 0.02 divided by 4, clicking enter, and then adding that answer to 1, clicking enter, raising that answer to an exponent of whatever that exponent is, in this case 4, click enter, multiply that answer by 1,000 by the principal, and click enter. Just because it gets a little bit annoying plugging in the calculator, but when you plug this in, we should end up getting what we got up here. We get $1,020. We actually get and 15 cents for this one, and that the only reason why we got a different answer is because we had a round in this previous one up here. We rounded a little bit, so we end up getting just a little bit off. Still, it was only a penny off, so it was still pretty close. So you can obviously see that this one is a lot easier to do. You only have to use one formula. Let's do another example. Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. If Kathy makes no other deposits in this account, determine the amount in the savings account after 2 years. So we know it's compounded interest because it's compounded monthly. And we're going to write down the formula. And let's write down our givens on the side here. The P is the 3,000, the amount invested, and the R is the interest rate, which is 1.8%. As a decimal, that's 0.018, and the N, the number of compounding periods, that's monthly, so that's going to be 12 times per year, so N is 12. And lastly, we have T. Our T value is 2 years. Now all we have to do is go ahead and plug it on in. So the total amount is going to be 3,000 times 1 plus 0.018 over 12, raised up to the 12 times 2. And plugging all of this in the calculator. So I'll write this one out actually the way I'd be plugging it in. We'll say that's 3,000 times 1 plus, dividing those two numbers, 0.018 divided by 12, we get 0.0015. And I'm going to do the exponent at the same time. 12 times 2 is 24. And now let's go ahead and add what's inside the parentheses. So try not to round, because rounding could make a decent difference. So adding these two numbers, we get 1.0015. And raise that number to the 24th. And I don't want to write down 1.0015 to the 24th, because I'm going to have to round, so I'm just going to avoid it by plugging it all in at the same time. And we end up getting about $3,109.88. And just make sure your answer makes sense. Originally invested $3,000 for 2 years. We ended up with $3,109.88. Okay, and then one more of these questions, and then we'll move on to the last thing. For example, calculate the interest on $3,000 at 4% compounded semi-annually for 7 years using the compound interest formula. So the first thing that I see is that we're looking for the interest. We're not looking for the total amount in the account. So we're going to end up having to subtract the answer that we get from the formula minus this original $3,000. But let's go ahead and do the formula first. So we have our compounded interest formula, and we have our P, which is $3,000, the original investment, and we have our R, the interest rate is 4%, that's 0.04. We have our N, this is semi-annually, that means twice per year, so N is 2, and we know T is the time in years, so T is 7. And let's go ahead and plug everything in. The total amount in the account after 7 years is going to be 3,000 times 1 plus 0.04 divided by 2 raised up to the 2 times 7. And plugging this in the calculator, we should end up getting about $3,958.44. So almost circled that. That's not our answer. That's the total amount in the account. We're looking for the interest. So we started with $3,000. We ended up with $3,958.44. So the interest is going to be us just subtracting those numbers. So that's going to be the A value that we just had minus the original principal. That's going to give us, right here, that's going to give us the $3,958.44 minus the original principal of $3,000. That gives us I equals $958.44. So that was the total interest for this particular question. So you just have to make sure you're reading the question and answering what it's actually asking for. Alright, so that brings us to the last thing. And this is the effective annual yield. So in making financial decisions, investors usually want to choose the investment that provides the highest interest rate, so they get the largest amount of money back. Or say we're trying to buy a car, we would probably want the lowest interest rate, so it's the lowest amount of money that we would have to pay back. But sometimes it can be hard to actually compare these interest rates. If one's in compound interest, the other's in simple interest, they may not line up that we can compare them nicely. So what we have for that to compare them is the effective annual yield. So the effective annual yield, which we also can call the annual percentage yield, APY, is the simple interest rate that gives the same amount of interest as a compound rate over the same period of time. So it essentially just gives us an answer for each one that allows us to compare them side by side. And the easiest way to determine the effective annual yield for any interest rate is going to be calculate the amount using the compound interest formula, where P is $1, then subtract $1 from that answer, and that difference, when we write it as a percent, is going to be the effective annual yield. So let's see a couple examples. Determine the annual percentage yield, or the effective annual yield, same thing, for $1 invested for 1 year at the following interest rates. Round your answers to the nearest hundredth of a percent. The first one is 2% compounded quarterly, and the next one is 3% compounded monthly. So these are both compound interest, but the rates are different. One is 2%, the other is 3%, and one is quarterly and the other is monthly. So it may not always be obvious which one is actually going to result in a larger interest. So let's figure out the effective annual yield for each one, and that will tell us which one would be a better interest. So for the 2% compounded quarterly, we are going to be using our formula for compounded interest. And let's write down our givens. We're going to use P equals 1, like was mentioned above. And we're going to use R is 0.02. That's the 2% compounded quarterly. N, since this is quarterly, it's going to be 4. And T is going to be 1, which once again, well, it mentions right here, 1 year and $1. Okay, so let's go ahead and plug all these in. We get A equals 1 times 1 plus 0.02 divided by 4 raised up to the 4 times 1. And plugging all of this in, we should get 1 rounded a little bit here. We get 1.0202. And like it says up here in the instructions, for subtract 1 from the amount, that's going to be the interest. So it's going to be A minus P. That's going to end up being the interest. So let's go ahead and do that. So A minus P, that's going to give us I equals A minus P. So that is 1.0202 minus 1. And that gives us I equals 0.0202. And let's go ahead and write this as a percent. And we get 2.02% when you move the decimal to the right 2, creating a percent. Okay, now let's check out the other one, 3% compounded monthly. We write down our formula, and we write down our givens. The principal, we're doing it for $1. The interest rate here is 3%, so 0.03. Compounded monthly, that's 12 compounding periods. And T, 1 year, just like it said in the question. And we plug all these in. We get 1 times 1 plus 0.03 over 12, raised up to the 12 times 1. And we plug all of this in the calculator, and we end up getting about 1.0304. And we do exactly what we did before. We do the total amount minus the original principal. So 1.0304 minus 1, and that's going to give us 0.0304. Okay, and then for this particular answer, it's going to be the same thing that we just set up here. We move the decimal 2 to the right, and we get 3.04%. So comparing these, the first one gave us 2.02%, and that one was compounded quarterly. The next one, compounded monthly at 3%, was 3.04%. So we can see that the 3% compounded monthly, that one is more. So if you're an investor, that one would be better because it's going to result in the greater interest. But if you're like taking out a loan, for an example, buying a car, then you're going to want the smaller one for smaller interest. So it completely depends on if you're the investor or if you're taking out a loan. Okay, so that is it for this chapter.